Hello students, welcome to 8th lecture of S block elements. So today we are going to discuss about some important compounds of calcium. So important compounds of calcium are calcium oxide, hydroxide, sulfate, carbonate and cement. These are the industrially important compounds, and the large scale preparation of these compounds and their uses are described below. So first is calcium oxide or quicklime calcium oxide. It is prepared on the commercially scaled by the heating limestone calcium carbonate in a rotary kiln at 1070 to 1270 Kelvin temperature. Rotary kiln is a device used to raise materials at high temperature, and this process is known as calcination. So it is this type of cylindric machine with complex structure inside. So for calcium carbonate, simple process will be when we heat it, it decomposes into calcium oxide and carbon dioxide. So carbon dioxide is removed as soon as it's produced to enable the reaction to proceed to completion. That means simply we are following the Le Chatelier's principle. According to Le Chatelier's principle, if you increase the concentration of the reactant, you can get forward reaction. Or if you can decrease the concentration of the product, you can get forward reaction. So in this reaction, calcium oxide and carbon dioxide, both of them are our products. So if we remove both of them or at least one of them, we are decreasing the concentration of the product and you can move in forward direction. So continuous removal of carbon dioxide can give us continuous production of calcium oxide, and eventually we will end up using complete reactant. So calcium oxide is a white amorphous solid. It has melting point of 2870 Kelvin. On exposure to atmosphere, it absorbs moisture and carbon dioxide. By absorbing moisture, it will form calcium hydroxide, and by absorbing carbon dioxide, it will form calcium carbonate. And because of these characteristics of calcium oxide, we can use it for dehydration purpose or to remove excess moisture from the reaction. The addition of limited amount of water breaks the lump of lime. This process is called slaking of lime. Quicklime slaked with the soda gives solid soda lime. Being a basic oxide, it combines with acidic oxides at higher temperature. So first CaO with SiO2 gives CaSiO3, and CaO with P4O10 gives Ca3PO4 twice. So uses of this compound: it is important primary material for manufacturing of cement, and it is cheapest form of alkali. It is used in the manufacture of sodium carbonate from caustic soda, and it is employed in the purification of sugar in the manufacturing of dye stuffs. Next is calcium hydroxide or slaked lime. Calcium hydroxide is prepared by addition of water to quicklime, as we discussed in previous point. It is a white amorphous powder. It is sparingly soluble in water. The aqueous solution is known as lime water, and suspension of slaked lime in water is known as milk of lime. When carbon dioxide is passed through the lime water, it turns milky due to the formation of calcium carbonate. So CaOH twice with carbon dioxide forms CaCO3 and H2O. Now this reaction is used to identify the presence of carbon dioxide in breath, or we can use the same reaction to prove plants also breathe like us. That means they inhale the oxygen and exhale carbon dioxide, and we already did this practical in primary standards. On passing excess of carbon dioxide, the precipitate dissolves to form calcium hydrogen carbonate. So calcium carbonate is insoluble compound in water, so it will precipitate out. On excess carbon dioxide, it will convert itself into calcium hydrogen carbonate, which is soluble compound. So CaCO3 with more carbon dioxide and water forms CaHCO3 twice, which is again soluble compound. So blurry solution will be cleared again. Milk of lime react with chlorine to form hypochlorite, a constituent of bleaching powder. So CaOH twice with 2Cl2, it gives CaCl2, CaOCl twice and H2O. And CaOCl twice NCaCl2 combined is known as bleaching powder. Uses: it is used in the preparation of mortar, a building material. It is used in whitewash due to its disinfectant nature. It is used in glass making, in tanning industry, for preparation of bleaching powder, and for purification of sugar. Next compound is calcium carbonate. Calcium carbonate occurs in nature in several forms like limestone, chalk, marble, etc. It can be prepared by passing carbon dioxide through the slaked lime or by the addition of sodium carbonate to calcium chloride. So we have to process CaOH twice with carbon dioxide gives CaCO3 and H2O. CaCl2 with Na2CO3 gives CaCO3 and NaCl. Excess of carbon dioxide should be avoided since it leads to the formation of water-soluble calcium hydrogen carbonate. Just we discussed in previous example. As mentioned in these two reactions, when calcium hydroxide with carbon dioxide gives calcium carbonate, excess quantity of carbon dioxide will lead us to calcium hydrogen carbonate. Calcium carbonate is white fluffy powder. It is almost insoluble in water. When heated at 1200 Kelvin, it decomposes to evolve carbon dioxide. So again, same reaction is mentioned. When calcium carbonate is heated at very high temperature, it decomposes into calcium oxide and carbon dioxide. It reacts with dilute acid to liberate carbon dioxide. So simple reaction, carbonate will turn into their respective salt depending on the acid used. If we are using HCl, it gives chloride. If you are using sulfuric acid, it gives sulfate, and along with it gives us water and carbon dioxide. Now uses of this compound: it is used as a building material in the form of marble and in the manufacturing of quicklime. Calcium carbonate along with the magnesium carbonate is used as a flux in the extraction of the metal such iron. Now flux are the material which are used to decrease the melting points. As mentioned in this case, iron metal has very high melting point. So we will mix it with certain material called flux which decreases the melting point so that our reaction can be done at lower temperature, and so it will be comparatively cheaper. Without flux, we need very high temperature to melt this metal or their compounds, and because of the high temperature requirement, we need to put more energy, which increase the cost. So specially precipitated CaCO3 is extensively used in the manufacturing of high quality paper. It is also used as an antacid, that means drug to treatment acidity, mild abrasive in the toothpaste. Abrasive are material which are rough in touch or they are used to scratching. A constituent of chewing gum and fillers in the cosmetics. Next is calcium sulfate, or known as plaster of Paris. It is calcium sulfate with half mole of water. It is hemihydrated of calcium sulfate. It is obtained when a gypsum calcium sulfate with 2H2O is heated at 393 Kelvin temperature. Now hemihydrate, that means we have two molecules of the compound per 1 mole of water. As we can see in the formula, we have CaSO4 1 half H2O. That means we have half H2O per 1 calcium sulfate. That means 1 H2O per 2 calcium sulfate. So simple reaction for the production: 2 CaSO4 twice H2O. When we heat it, you will get 2 CaSO4 1 H2O, and water will be removed. Above 393 Kelvin, no water of crystallization is left, and anhydrous calcium sulfate CaSO4 is formed. This is known as dead burnt plaster. It has remarkable property of setting with water. On the mixing with adequate quantity of water, it forms plastic mass that gets into a hard solid in 5 to 10 minutes. So that's why we use plaster of Paris for the molding purpose, for the designing and for idol creation, etc. Now uses: the largest use of plaster of Paris is in the building industry as well as plasters. It is used for immobilizing the affected parts of organ where there is a bone fracture or sprain. That means we are talking about the plaster used during the fractures. It is also employed in dentistry, that means for teeth related surgeries, in ornamental work, and making the cast of the statues and busts. Next is cement. So cement is an important building material. It was first introduced in England in 1824 by Joseph Aspardin. It is also called Portland cement because it resembles with the natural limestone quarried in Isle of Portland, England. The cement is a product obtained by the combining the material rich in lime CaO with other materials such as clay with containing silica SiO2 along with the oxides of aluminium, iron, magnesium, etc. The average composition of Portland cement is calcium oxide 50 to 60%. So main component is calcium compound. Silica SiO2 20 to 25%, aluminium oxide 5 to 10%, MgO 2 to 3, Fe2O3 1 to 2 and SO3 1 to 2%. For a good quality cement, the ratio of silica to aluminium should be between 2.5 to 4 and the ratio of lime to the total of the oxide of the silicon SiO2, aluminium and iron should be as close as possible to 2. The raw material for the manufacture of the cement are limestone and clay. When the clay and limestone are strongly heated together, they fuse and they react to form cement clinker. This clinker is mixed with 2 to 3% by weight for gypsum, which is calcium sulfate. To form cement, thus important ingredients present in the Portland cements are dicalcium silicate 26%, tricalcium silicate Ca3SiO5 51% and tricalcium aluminate Ca3Al2O6 11%. Now settling of cement, that means the use of cement. When the mixture with water, the settling of cement takes place to give hard mass. This is due to the hydration of the molecules of the constituent and their rearrangement. The purpose of addition of gypsum is only to slow down the process of settling of the cement so that it gets sufficiently hardened, so that we also get the time to properly fit it. Now uses of cement, we are well aware of it. Cement has become a commodity of the national necessity for any country next to the iron and steel. It is used in concrete and reinforced concrete, in plastering and in the construction of bridges, dams and buildings. And now last point of the unit, biological importance of magnesium and calcium. An adult body containing about 25 grams of magnesium and 1200 grams of calcium compared with only 5 grams of iron and 0.06 grams of copper. Now note here, calcium is one of the main component in our bones and that's why it is mentioned in comparatively large quantity. The daily requirement in the human body has been estimated to be 200 to 300 milligrams. All the enzymes that utilizes ATP in phosphate transfer require magnesium as the cofactor. Now cofactor generally helps in the reactions. The main pigment for the absorption of light in plant is chlorophyll, which contains the magnesium. About 99% of body calcium is present in the bones and the teeth. It is also played important role in the neuromuscular functions. So as mentioned, neuromuscular, so it uses neurons and muscles. So we can say that it is the transition system to the muscles. And also in interneuronal transmission, cell membrane integrity and blood coagulation. The calcium concentration in plasma is regulated at about 100 milligrams per liter. It is maintained by two hormones, calcitonin and parathyroid hormone. Now do you know that bone is not an inert and unchanging substance, but it is continuously being solubilized and redeposited to the extent of 400 milligrams per day in man. So simple reason, this is why our bones are healing. Okay, when we broke the bone, with the help of plaster we are stabilizing their positions, we are holding them in positions, and as we can see here, they are continuously solubilized and redeposited. So they will deposit the calcium on the crack on the bone, and that's why we can heal it. So all this calcium is passed through the plasma. So now unit is complete. If you find any difficulties in any point, feel free to ask and go through the exercise. If you find any difficult question, then you can ask me and we will discuss it in detail. Thank you.